Hello there, and welcome to the Sleep with Science channel. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps the channel to reach more curious minds like yours. Now let's begin. Close your eyes for a moment, and let your breath grow slow. Tonight, I am going to take you somewhere most people never think about. Somewhere past the last planet you learned about in school. Somewhere the sunlight becomes so thin, so faint, so nearly gone, that if you stood there and looked back toward home, our sun would shrink into something you could almost cover with a single grain of sand held at arm's length. There is a place beyond Neptune. A vast, dark, frozen frontier that our own spacecraft have barely brushed against. And the strange truth is this. We have mapped more of the ocean floor on our own planet than we have of this region. We know more about the surface of Mars than we know about what drifts, silently, endlessly, in the dark beyond the eighth planet. Scientists have a name for it. The Kuiper Belt. But a name is such a small, tidy word for something this immense, this old, this quietly unsettling. Because out there, in that frozen ring circling our solar system, there are hundreds of thousands of icy worlds. Not a handful. Not a dozen. Hundreds of thousands, at minimum, each one larger than 60 miles across, and untold trillions of smaller icy fragments beyond counting. Some of these objects have never once been seen by human eyes, not even as a pixel of light in the most powerful telescope we have ever built. They simply drift, in absolute silence, in a cold so complete it is almost impossible for the human mind to imagine. Temperatures out there hover near 400 degrees below 0 Fahrenheit. Cold enough to freeze the very air you are breathing right now, solid, in seconds. And here is the part that tends to keep people awake at night, staring at their ceiling, turning it over and over in their minds. We do not know what is out there. Not really. Not fully. When NASA's New Horizons spacecraft became the first, and so far only, spacecraft to closely study this region, flying past the icy world of Arikoth in 2019, it sent back images of something so strange, so unlike anything in our solar system, that scientists had to invent new language just to describe its shape. A flattened, reddish, two-lobed object, stuck together billions of years ago in the birth of our solar system, and preserved, untouched, ever since. A frozen fossil from the very beginning of everything. And that was just one object. One out of hundreds of thousands. Let that settle into you for a moment. Just breathe, and let it settle. Now, let us go back. Back to the very beginning, because to understand this strange, shadowed region, you first have to understand where it came from, and why it exists at all. Roughly 4.5 billion years ago, our solar system was nothing but a vast, swirling cloud of gas and dust, spinning slowly in the dark. At its center, gravity pulled matter inward, compressing it, heating it, until it ignited into the sun we know today. But not everything fell inward. Far from that new fire, in the cold outer reaches of the swirling disk, smaller clumps of ice and rock began to gather. Slowly, patiently. Over millions upon millions of years, these fragments collided gently, again and again, sticking together, growing larger, forming what scientists call planetesimals. Some of these growing bodies eventually became the massive gas giants, Jupiter, Saturn, Uranus, and Neptune, whose immense gravity reshaped the entire outer solar system. But out beyond Neptune, something different happened. The material was too sparse, too cold, too slow-moving to ever fully assemble into a proper planet. And so it simply stayed there. Frozen. Unfinished. A vast, scattered ring of leftover material from the solar system's earliest childhood, never gathered into something larger, never melted, never reshaped by heat or volcanic activity the way Earth was. Which means that every single object out there, every icy world, every drifting fragment, is essentially a time capsule. A frozen piece of the earliest moments of our solar system's formation, drifting undisturbed for over 4 billion years. Astronomers first began to suspect something like this might exist long before they could prove it. In the middle of the 20th century, a small handful of scientists looked at the orbits of certain comets that seemed to swing by every 200 years or so, and they began to wonder, where were these icy visitors coming from? What hidden reservoir out beyond Neptune kept sending them our way? It would take decades of patient searching, decades of staring into the coldest, darkest corner of our night sky, before anyone actually found proof that this shadowed region was real. And that proof, when it finally came, arrived quietly. Not with fanfare. Not with headlines splashed across every newspaper in the world. It arrived on the night of August 30th, 1992, in the stillness of an observatory in Hawaii, high atop the dormant volcano of Mauna Kea, where the air is thin and the sky above is some of the darkest and clearest on our entire planet. Two astronomers, David Jewett and Jane Liu, had spent 5 long years searching. Night after night, they pointed their telescope into the same dark patch of sky beyond Neptune, waiting, watching, comparing photograph after photograph, looking for the faintest possible speck of light that moved, ever so slightly, against the fixed and distant stars. Most nights, they found nothing at all. Just static. Just darkness. Just the quiet, patient work of searching for something that might not even exist. But on that particular night, after 5 years of searching, they found it. A tiny, impossibly faint object, barely a whisper of reflected sunlight, drifting slowly through the blackness roughly 4 billion miles from Earth. They named it 1992 QB1. It was small, only about 100 miles across, and yet its discovery changed everything we understood about our solar system. Because here, at last, was proof. Proof that the frozen ring first theorized decades earlier truly existed. Proof that Neptune was not, in fact, the outer edge of our solar system, but simply a doorway into something larger, older, and far stranger. I want you to imagine, for a moment, what that must have felt like. 5 years of quiet, disciplined searching, alone in the cold night air, high on a mountain, staring at black and white photographic plates under dim red light so as not to disturb your night vision. 5 years of doubt, of near misses, of empty frames. And then, suddenly, there it is. A single point of light, moving where nothing should be moving, confirming a truth that had been waiting, patiently, for over 4 billion years, simply for someone to notice it. Let that feeling settle into you now, as your body grows heavier, and your breathing continues to slow. Once that first object was found, the discoveries did not stop. They accelerated. Within just a few years, dozens more icy worlds were found drifting in that same shadowed region. Then hundreds. Then thousands. Astronomers began to realize that this was not a sparse, empty ring, but a rich, populated frontier, filled with icy bodies of every size, from small drifting fragments no larger than a mountain, up to entire dwarf planets, some of them rivaling the size of Pluto itself. And speaking of Pluto, this is where our story bends in a direction that surprised almost everyone, including the scientists themselves. Because Pluto, that small, cold, distant world discovered in 1930 by a young astronomer named Clyde Tombaugh, had always been considered strange. Too small. Too icy. Its orbit tilted at an odd angle compared to the tidy, flat orbits of the other planets. For over 60 years, scientists quietly wondered why Pluto seemed so different from everything else in our solar system. And then, with the discovery of this vast frozen belt beyond Neptune, the answer became clear. Pluto was never truly alone. Pluto was never some strange, singular oddity drifting at the edge of everything. Pluto was simply the first, and for a long time the only member of an enormous, hidden family that astronomers hadn't yet found. It was not an outlier. It was a resident. One of hundreds of thousands of icy worlds belonging to this same shadowed region, this same frozen ring, that we now call the Kuiper Belt. This realization, slow and quiet as it was, reshaped our entire understanding of the solar system structure. We had always been taught, so simply, so confidently, that our solar system consisted of the Sun, followed by 8, or once, 9 planets, arranged neatly like beads on a string, and then nothing. An edge. A boundary. The end of the map. But that was never true. It was never that simple, and it was never that small. Beyond Neptune, the true boundary of our solar system continues on, and on, and on, into a realm so vast that its outer edges remain, even now, essentially unmapped. A realm filled with objects so cold, so distant, and so ancient, that studying them is, in many ways, like studying fossils. Except instead of digging through layers of rock and sediment here on Earth, astronomers are searching through layers of darkness and distance, searching for frozen relics that have remained almost completely unchanged since the very birth of our Sun. And here is something worth sitting with, as your mind begins to drift further into stillness. The very belt we are describing tonight, this shadowed frozen ring beginning just past Neptune's orbit, does not end where most people assume it does. It doesn't simply stop at some clean, tidy boundary a short distance beyond the 8th planet. It stretches on, far past what most casual observers of the night sky ever imagine, into a region so distant that sunlight itself becomes almost meaningless, a faint gray twilight that never truly changes, hour after hour, year after year, century after century, drifting on in that same eternal, frozen dusk that has existed since long before. The Earth itself had even finished cooling into the world we know today. Since long before the first oceans filled their basins. Since long before the first single-celled organisms stirred in the shallow warmth of ancient seas. That frozen twilight has simply persisted, unchanging, indifferent, patient, out there in the dark, for over 4 billion years. Let us sit with the scale of this place for a while now, because the human mind, quite understandably, struggles to hold numbers this large. We are used to thinking in miles we might drive in a car, or perhaps the distance of an airplane flight across an ocean. But the Kuiper Belt does not measure itself in numbers like that. It begins roughly 2.5 billion miles from the Sun, right around Neptune's orbit, and it stretches outward from there to somewhere between 4 and 4.5 billion miles. To help that number settle into something imaginable, consider this. Light itself, the fastest thing in our entire universe, the same light that reaches your eyes from a lamp across the room in a fraction of a second, takes over 4 hours just to cross that region once. 4 hours, traveling at 670 million miles per hour, simply to pass through this one shadowed ring of our solar system. And within that staggering expanse of space, drifting in near total darkness, scientists now believe there are more than 100,000 icy objects larger than 60 miles across. That number alone should give you pause. 100,000, at the very least, and this is simply the count of the larger bodies. When you begin to include the smaller fragments, the countless chunks of ice and rock and frozen gas ranging from the size of a mountain down to the size of a pebble, the true number climbs into the trillions. Trillions of individual objects, drifting silently, spread across a region so vast that even trillions of objects can feel remarkably sparse, isolated from one another by millions of miles of empty, frozen dark. This is one of the strange truths about the Kuiper Belt that often surprises people. Despite the almost incomprehensible number of objects out there, the region itself is not crowded. It is not the chaotic, rock-strewn field of destruction that certain films and television shows might lead you to imagine, with debris colliding and tumbling past each other in rapid succession. No. The true nature of the Kuiper Belt is one of profound isolation. If you were to stand on the icy surface of one of these distant worlds and look outward in any direction, you would very likely see nothing else at all. No neighboring worlds. No visible companions. Only the endless black of space, scattered with the same distant, unmoving stars, and somewhere among them, one particular point of light, smaller and fainter than any star around it, that happens to be our own sun. From that distance, sunlight would provide barely any warmth at all, arriving as little more than a pale, cold glow, roughly 1,000 times fainter than the daylight we take for granted here on Earth. Try to imagine standing there, on that frozen ancient surface. The silence would be absolute, of course, because sound cannot travel through the vacuum of space. But imagine, just for a moment, if you could hear something out there. What would it even sound like? Perhaps nothing but the faint, imagined hiss of solar wind, brushing past ice that has not felt warmth in over 4 billion years. Perhaps nothing at all. Just an endless, perfect stillness, a silence so complete it becomes almost its own kind of presence, wrapping around you in the dark. It is this silence, this isolation, this staggering scale, that makes the Kuiper Belt such an unusual place to think about as you drift towards sleep tonight. Because unlike so many of the more dramatic corners of our universe, unlike the violent collapse of a dying star, or the crushing gravity of a black hole tearing matter apart, the Kuiper Belt offers something quieter. Something slower. It does not roar. It does not explode. It simply waits, patient and unchanged, the way it has waited for over 4 billion years, holding within its frozen worlds the earliest secrets of our solar system's birth. And yet, despite that quiet, despite that stillness, there remains something undeniably unsettling about a region this vast, this close, in cosmic terms, to our own home, and yet so profoundly unknown to us. We have sent exactly one spacecraft to study it closely. We have mapped, in detail, only a small handful of its hundreds of thousands of worlds. The rest remains hidden, drifting somewhere out there in the frozen dark, waiting, as they always have, for someone or something to finally come looking. Let us drift now toward one particular corner of that frozen ring, toward a world that has, more than any other object out there, captured the imagination of scientists and dreamers alike. A world that, for the better part of a century, held the title of 9th planet in our solar system, before a deeper understanding of its true neighborhood quietly, gently, reclassified it into something else entirely. I am speaking, of course, of Pluto. And tonight, I want you to set aside whatever you learned about Pluto in a classroom years ago, because the real story of this small, distant world is far stranger and far more beautiful than any textbook diagram ever managed to capture. Pluto orbits the Sun at an average distance of roughly 3.7 billion miles, though its path is not a neat, tidy circle like the orbits of the inner planets. Instead, Pluto follows a long, elongated ellipse, so stretched that at its closest approach, it actually drifts slightly inside the orbit of Neptune, before swinging back out, over the course of 248 years, to the farthest reaches of its long, lonely path. Think about that number for a moment, as your body continues to settle, heavier now, into stillness. 248 years. A single orbit around the Sun, for this small icy world, takes longer than the entire history of the United States as a nation. Every person alive on Earth today was born, will live their entire life, and will pass on, all within a single fraction of one Plutonian year. For decades, Pluto was little more than a faint smudge of light in even the most powerful telescopes on Earth, its surface a complete mystery, its details entirely unknown. That changed on July 14, 2015, when NASA's New Horizons spacecraft, after a journey of 9.5 years and more than 3 billion miles, finally swept past Pluto at over 30,000 miles per hour, capturing the first clear, detailed images humanity had ever seen of this distant world. And what those images revealed left scientists astonished. Pluto was not the dead, cratered, featureless ball of ice many had expected. Instead, its surface told a story of astonishing, ongoing activity. Vast plains of frozen nitrogen ice, smooth and unbroken by craters, suggesting the surface had been resurfaced, geologically renewed, in relatively recent times. Towering mountains of solid water ice, some rising as high as 11,000 feet, comparable to peaks in the Rocky Mountains, yet built not from rock, but from ice as hard as stone in the deep cold of that distant realm. And at the heart of it all, a massive, pale, heart-shaped region of nitrogen ice now known as Tombeau Regio, named in honor of the young astronomer who first discovered Pluto, spanning nearly 1,000 miles across, visible even from the approaching spacecraft, as if this small, frozen world had been quietly waiting billions of years just to reveal that particular shape to us at just the right moment. Beneath that icy heart, scientists now believe there may lie something even more remarkable. Evidence suggests the possibility of a subsurface ocean, a vast reservoir of liquid water, kept from freezing solid by heat generated deep within Pluto's rocky core, insulated by thick layers of ice above. An ocean, hidden beneath the frozen surface of a world nearly 4 billion miles from the Sun, in a place where daylight itself is little more than a rumor. Consider that, for a moment, as you continue to breathe slowly, and let your thoughts drift outward into that distant dark. Liquid water, the very substance so closely tied to the origins of life as we understand it here on Earth, may exist right now, in complete darkness, sealed away beneath miles of ice, on a small world at the very edge of what we once considered the boundary of our solar system. And Pluto does not drift through that frozen dark entirely alone. It carries with it 5 known moons, the largest of which, Charon, is so massive relative to Pluto itself that the two worlds do not orbit in the way most planets and moons do. Instead, they orbit a shared point of balance in the space between them, locked together in a slow, silent gravitational dance that has likely continued, unbroken, for billions of years. If you stood on Pluto's surface, gazing upward, Charon would hang motionless in the sky, always in exactly the same place, never rising, never setting, simply fixed there, forever, a silent companion in the endless twilight, watching, unmoving, as the frozen centuries continue to pass by, one after another, in that vast and distant quiet, far beyond anything we have ever truly understood or ever truly known. For Charon itself is no simple stone, no lifeless companion drifting through the dark by accident. Its surface tells a story written in canyons deeper than anything carved into the crust of Earth, a vast system of fractures and cliffs called Serenity Chasma, stretching for hundreds of miles across its face, evidence of a frozen ocean that once, long ago, expanded and cracked the moon's outer shell from the inside, like water freezing within stone until the stone itself could no longer hold together. And near Charon's north pole lies a strange darkness, a reddish cap of material scientists call Mordor Macula, a place where gases escaping from Pluto's thin atmosphere may drift across the space between the two worlds, settling onto Charon's frozen surface, transforming under the faint touch of solar radiation into complex reddish molecules called tholins. A slow, patient exchange between two bound worlds, each shaping the other in ways that unfold across timescales too vast for a single human mind to hold. And beyond Charon, smaller moons continue the quiet procession, names drawn from the mythology of the underworld itself: Nyx, Hydra, Kerberos, Styx, each one tumbling through space in ways that defy the calm, predictable rotation we associate with moons closer to the Sun. For these small, distant worlds do not rotate steadily, the way our own moon does, always presenting the same face to Earth. Instead they tumble, chaotically, unpredictably, their spins influenced by the complex gravitational tug-of-war between Pluto and Charon, a dance so intricate that these tiny moons can never settle into a stable rhythm. If you could stand upon one of them, the sky itself would seem to spin in ways no human eye evolved to expect, the stars sliding, tumbling, wheeling overhead in patterns without pattern, a universe unmoored from the gentle order we take for granted so much closer to the Sun. And still, Pluto and its moons are only one small cluster of light and stone within a region so vast that even our most powerful instruments have only begun to map its true scale. The Kuiper Belt stretches outward from roughly 30 times the distance between Earth and the Sun, out past 50 times that distance, a donut-shaped realm of icy debris encircling our solar system like some vast and silent ring, holding within it hundreds of thousands of objects larger than 60 miles across, and untold trillions of smaller fragments, comets in waiting, worlds that never finished forming, remnants of a solar system that could have been. Because that is, perhaps, the deepest truth hidden within this frozen region. The Kuiper Belt is not simply a graveyard of leftover material. It is a monument to unfinished creation. In the earliest days of our solar system, nearly 4.5 billion years ago, the same disk of gas and dust that formed the Sun and the inner planets also extended out into this distant region. But out here, so far from the Sun's gravitational grip, so far from the warmth needed to accelerate collisions and mergers, the process of planet formation simply ran out of time. The particles were too sparse, too cold, too slow-moving to coalesce into anything larger than these scattered dwarf worlds and icy fragments. And so the Kuiper Belt remains, even now, a frozen snapshot of what our solar system looked like in its infancy, a preserved fragment of creation interrupted, drifting eternally in the dark. Some scientists have described it as a kind of cosmic archive, a place where the original chemistry of the solar system's birth remains locked away, largely unchanged, protected by the very cold and distance that make it so inhospitable to us. While the inner planets were reshaped again and again by volcanic activity, by asteroid bombardment, by the endless churn of geological time, the objects of the Kuiper Belt have remained largely undisturbed, their surfaces still holding traces of the primordial ices and organic compounds that existed before Earth itself had fully formed. To study the Kuiper Belt, then, is to look backward through time itself, to glimpse the raw ingredients from which our entire solar system was built, before life, before oceans, before anything resembling the world we now call home. And yet, for all its scientific significance, the Kuiper Belt remains one of the least explored regions of our solar system, a vast wilderness through which only a single spacecraft, New Horizons, has ever truly passed, capturing fleeting glimpses of a handful of these distant worlds before continuing outward, deeper still, into the dark beyond. Beyond the reach of its cameras, beyond the narrow path it traced through this endless field of ice, countless other worlds remain utterly unseen, uncharted, waiting in silence for a future we cannot yet predict, a future in which humanity might finally turn its full attention toward this frozen frontier and begin to understand, in far greater detail, the strange and ancient truths it has kept hidden for billions of years, drifting quietly at the edge of everything we have ever known, waiting, patient, unmoving, for the moment when we finally choose to look closer, and to ask what other secrets might be waiting in that frozen dark for eyes patient enough to find them. Consider, for a moment, the sheer difficulty of simply seeing what lies within the Kuiper Belt at all. These are not bright, self-luminous objects announcing their presence across the void. They are cold, dark bodies, reflecting only a faint whisper of sunlight that has already traveled billions of miles before ever touching their surfaces, and must then travel billions of miles more before reaching any telescope capable of detecting it. At such distances, the Sun itself would appear not as the warm, dominant presence we know from Earth, but as a small, brilliant point of light, still the brightest object in the sky, yet reduced to something closer to a very bright star, casting a pale, thin illumination across landscapes of frozen nitrogen and methane ice. To stand upon one of these distant worlds would be to exist in a perpetual twilight, a realm where daylight itself is little more than a rumor of the warmth that governs the inner solar system. And it is within this dim, frozen twilight that some of the most peculiar objects in our entire solar system quietly drift. Consider Haumea, a dwarf planet unlike almost anything else we have discovered, spinning so rapidly upon its axis, completing a full rotation in under 4 hours, that the object itself has been stretched by its own centrifugal force into a strange, elongated shape, more like a football than a sphere. Scientists believe this extraordinary spin may be the result of an ancient, cataclysmic collision, a violent impact so powerful that it not only reshaped Haumea itself but also flung fragments of icy debris outward, fragments that may have gone on to form Haumea's own small family of moons, and possibly even a scattered trail of icy debris that follows the dwarf planet through its long, slow orbit. To gaze upon Haumea, if such a thing were possible, would be to witness a world caught in the frozen aftermath of violence, still spinning, still stretched, still bearing the shape of some ancient catastrophe billions of years in the past. And further out still, drifting even more slowly through the dark, lies Makemake, a dwarf planet named for a creation deity of the Rapa Nui people of Easter Island, its surface coated in frozen methane and ethane, reflecting sunlight with a faint reddish hue that hints at complex organic chemistry occurring even in such extreme cold. Makemake takes over 300 years to complete a single orbit around the Sun, meaning that in the entire span of recorded human civilization, this distant world has not yet completed even one full journey around the star that gives it what little light it receives. To imagine such a timescale is to confront, once again, the strange smallness of human experience against the vast, patient rhythms of the outer solar system, where a single year can stretch longer than the entire history of nations, longer than the rise and fall of empires, longer than nearly everything we consider permanent within our brief human lives. And then there is Eris, discovered in the early 21st century, a dwarf planet so distant, so cold, so slow-moving that its very discovery forced astronomers to reconsider what a planet truly is, ultimately leading to the reclassification of Pluto itself. Eris travels an orbit so eccentric, so elongated, that its distance from the Sun varies dramatically over the course of its long journey, swinging from relatively close proximity within the Kuiper Belt itself out to distances nearly 3 times greater, into a region so remote that sunlight becomes little more than a distant memory of warmth. At its most distant point, Eris exists in a darkness so profound that its frozen atmosphere, what little exists, is believed to collapse entirely, falling as frost onto its surface, only to sublimate back into a thin haze of gas as the dwarf planet slowly, over centuries, begins its long return toward the Sun. These worlds, Haumea, Make, Eris, and countless others yet unnamed, unnumbered, undiscovered, drift through the Kuiper Belt not as isolated curiosities, but as pieces of a much larger, much older story, fragments of the same primordial disk that gave birth to every planet, every moon, every world we have ever known. And yet, unlike the planets closer to the Sun, these distant bodies were never swept up, never merged into larger structures, never given the chance to become something more. They remain, instead, exactly what they always were, frozen relics of creation, drifting endlessly through a darkness so vast, so complete, that even the light of our Sun struggles to reach them, arriving not as warmth, but as memory, a faint and fading reminder of the fire that first gave birth to everything within this solar system, including, somewhere impossibly far behind these frozen worlds, the small, blue, living planet we call home, though from such a distance, even that word begins to lose its meaning, begins to feel less like a place and more like a memory of warmth carried inside the mind of whoever dares to imagine standing upon these frozen shores. For that is perhaps the strangest truth of the Kuiper Belt, that scale itself becomes almost impossible to comprehend once you cross the orbit of Neptune. We speak of these distances in astronomical units, each one representing the space between Earth and the Sun, roughly 93 million miles, and yet even this unit, vast as it already seems, becomes almost meaningless once applied to the outer reaches of the belt. Eris, at its most distant, drifts nearly 97 astronomical units from the Sun, which means light itself, the fastest moving thing in the entire universe, requires more than 13 hours simply to travel from the Sun to that lonely, frozen world. 13 hours of travel, at a speed of nearly 670 million miles per hour, simply to cross the gap between a star and one small, icy body drifting at the edge of its gravitational reach. And still, even at such staggering distances, Eris remains gravitationally bound to our Sun, still completing its slow, silent orbit, still, in some fundamental sense, belonging to the same solar system as Earth, as Mars, as every world we have ever known. It is difficult, perhaps even impossible, for the human mind to truly hold such distances in any meaningful way. We are creatures built for smaller scales, for the distance between one tree and another, one town and the next, one lifetime measured against another. Our intuition simply was not designed to comprehend a void this vast, this empty, this patient. And yet, in a strange way, this very incomprehension may be part of what makes the Kuiper Belt so quietly terrifying, not in the sense of monsters lurking in the dark, not in the sense of danger reaching toward us from the void, but in the deeper, more existential sense of confronting just how small our entire civilization truly is against the backdrop of such staggering scale. Every war ever fought, every empire ever built, every love ever felt, every book ever written, all of it unfolded upon a single small world, drifting within a bubble of light and warmth so small that it would scarcely register as a single point within the vast, cold darkness stretching outward from Neptune's orbit into the Kuiper Belt and beyond. And perhaps this is why the Kuiper Belt unsettles something deep within us, something beyond simple curiosity. It is not merely a region of space. It is a mirror of sorts, reflecting back the profound isolation of our own existence, reminding us that everything we know, everything we have ever built, exists within an almost impossibly narrow band of habitability, a fragile pocket of warmth and light surrounded, in every direction, by darkness so vast, so cold, so ancient, that human civilization itself is little more than a passing flicker, a brief spark of light against the overwhelming silence of the void. And yet, within that silence, there is also something strangely comforting, something almost meditative. For the Kuiper Belt does not rage. It does not churn with violence the way some regions of space do, racked by stellar explosions, by the collapse of dying stars, by the chaos of newborn solar systems still tearing themselves apart. The Kuiper Belt, instead, exists in a state of profound stillness, a slow, patient quiet that has remained largely unchanged for over 4 billion years. Its objects drift not with urgency, but with the unhurried patience of deep time itself, tracing their long, slow orbits again and again, indifferent to the passage of human history, indifferent to the rise and fall of civilizations, indifferent, even, to the eventual fate of our own sun. For someday, though not within any timescale a human mind can truly grasp, our sun itself will change, will swell, will eventually shed its outer layers and fade into a slow, cooling ember. And when that day finally comes, when the inner solar system is reshaped by the sun's own transformation, the Kuiper Belt, distant, cold, and largely untouched by such changes, may remain remarkably unaffected, its icy worlds continuing their slow orbits long after Earth itself has ceased to exist in any recognizable form. In this way, the Kuiper Belt is not simply a relic of the solar system's ancient past. It may also become one of the final witnesses to its distant future, drifting on in silence long after everything we have ever known has faded into memory, long after the light of our sun has dimmed into something colder, quieter, and infinitely more patient than anything we, in our brief and fleeting lives, could ever hope to fully understand, though understanding, perhaps, was never truly the point of looking outward at all. Perhaps it was always something closer to reverence, a quiet acknowledgement of scale so vast that comprehension gives way, gently, to something more like awe. And within that awe, there remains still so much we do not know about the Kuiper Belt, so many questions that continue to drift, unanswered, in the same darkness as the objects themselves. Consider, for a moment, the strange alignment discovered among a cluster of distant Kuiper Belt objects, bodies whose orbits appear to cluster together in ways that should not occur naturally, their elongated paths pointing in remarkably similar directions, as though influenced by the gravity of something massive, something unseen, something perhaps still waiting to be discovered far beyond the reach of our current instruments. Some astronomers have proposed that this strange clustering might be evidence of a ninth planet, a world perhaps 5 to 10 times the mass of Earth, orbiting the Sun at a distance so vast, so extreme, that a single orbit might take between 10 and 20,000 years to complete. A planet, if it exists, that no human being has ever seen, ever named, ever truly confirmed, drifting somewhere in the darkness beyond even the Kuiper Belt itself, exerting a slow, silent influence over smaller worlds without ever revealing its own presence directly. To imagine such a planet is to imagine something almost mythic in scale, a world so distant that its very light, faint and cold, has likely never once been captured by any telescope pointed in the right direction at the right time. And yet, its gravitational fingerprint may already be written across the orbits of these smaller, more distant Kuiper Belt objects, a signature hidden in plain sight, waiting for the right eyes, the right instruments, the right moment of discovery to finally reveal what has, until now, remained only theoretical. Some have called this hypothetical world Planet 9. Others have speculated it might not be a planet in the traditional sense at all, but something stranger still, perhaps even a small, ancient black hole, no larger than a grapefruit, yet possessing enough mass to bend the orbits of everything around it, a silent, invisible presence lurking at the outer edge of our solar system, detectable only through the subtle gravitational traces it leaves behind. Whether such a planet, or such an object, truly exists remains one of the great unresolved mysteries of modern astronomy, a question that continues to drive astronomers to search deeper, wider, more patiently into the darkness beyond Neptune, scanning the sky night after night, hoping to catch even the faintest glimmer of reflected sunlight from a world that may have been quietly orbiting our sun since the very beginning of the solar system itself, utterly unseen, utterly unknown, for over 4 billion years. And even if Planet 9, or whatever unseen mass may be responsible for these strange alignments, is never definitively found, its very possibility reminds us of something profound about the region beyond Neptune, that even after centuries of observation, even after decades of space exploration, even after the incredible achievements of missions like New Horizons, we have still only begun to glimpse the true complexity of our own solar system's outer reaches. And it is not only massive, hypothetical planets that continue to elude us. The Kuiper Belt itself remains only partially mapped, its full population of objects still largely uncatalogued, with new discoveries continuing to emerge with each passing year as our telescopes grow more powerful, our survey techniques more refined. Every new object discovered adds another small piece to an immense, unfinished puzzle, another fragment of understanding about how our solar system formed, how it evolved, and what still remains hidden within its outermost regions. And with each new discovery comes not fewer questions, but more, for the Kuiper Belt has proven, again and again, to be a region far stranger, far more complex, and far more diverse than early astronomers ever imagined when Pluto was first discovered in 1930, back when scientists believed they had found nothing more than a single small, icy world drifting alone at the edge of the solar system. Now we understand that Pluto was never alone at all, that it was merely the first visible marker of an entire hidden realm, a vast frontier extending far beyond what any telescope of that era could have possibly detected. And as our understanding continues to grow, as new missions are proposed, as new technologies are developed capable of peering even further into this frozen darkness, one truth becomes increasingly clear, that the boundary of our solar system is not a fixed, simple line, but a slow, gradual fading into deeper and deeper layers of mystery, each one more distant, more silent, and more ancient than the last, receding into a darkness so complete that light itself begins to lose meaning as a concept, where the sun, once a blinding and dominant presence, has shrunk to little more than a single brilliant star among countless others, indistinguishable to the casual glance, a pinprick of white fire hanging in a black so absolute that the mind struggles to comprehend it. Consider, for a moment, what sunlight actually means at these distances. Here on Earth, we take its warmth for granted, its ability to cast shadows, to differentiate day from night, to nurture every living thing across the surface of our world. But travel far enough into the Kuiper Belt, and that same sun becomes almost theoretical, its light arriving so faint, so diffuse, that it can no longer perform any of the functions we associate with it. It does not warm. It barely illuminates. It exists more as a directional reference than as a source of life, a distant reminder that somewhere, unfathomably far away, there is a place where light still matters. This is the strange threshold the Kuiper Belt occupies, a region caught between belonging and not belonging, still gravitationally bound to our star, still completing its slow orbits across tens of thousands of years, and yet existing in conditions so extreme that the word solar system begins to feel almost inadequate, almost too warm and too familiar for what is actually out there. Temperatures in this region hover consistently near 40 degrees above absolute zero, cold enough that gases we consider common on Earth, methane, nitrogen, carbon monoxide, exist not as invisible vapors but as solid ices, frozen into the crusts of countless small worlds, waiting in perfect stillness for a warmth that will never come. And it is this stillness, this profound and unbroken quiet, that gives the Kuiper Belt its particular character among all the regions of the solar system. Unlike the asteroid belt, where collisions occur with relative frequency, where the gravitational influence of nearby Jupiter constantly stirs and disturbs the population of rocky bodies, the Kuiper Belt exists at such vast distances, with such enormous spaces between individual objects, that collisions become almost unthinkably rare events, occurring perhaps once every few million years for any given body. Most Kuiper Belt objects will complete their entire existence, their entire multi-billion-year journey around the Sun, without a single meaningful interaction with another object. They simply drift, alone, silent, unchanging, carrying within them a kind of geological patience that nothing on Earth could ever replicate. This is part of what makes the region so scientifically precious, and also, in its own way, so unsettling to contemplate. These are not merely distant rocks. They are time capsules, preserved almost perfectly since the earliest days of the solar system's formation, roughly 4.5 billion years ago, when the Sun was newly ignited and the planets were still assembling themselves from a swirling disk of gas and dust. While Earth's surface has been reshaped again and again by volcanism, by erosion, by the endless churn of plate tectonics, while even the Moon has been scarred and resurfaced by billions of years of impacts, many Kuiper Belt objects remain almost exactly as they were in those earliest chapters of solar system history. To study them is to look backward across an almost incomprehensible span of time, to see, preserved in ice and rock, the raw ingredients from which everything else, including us, eventually formed. And yet knowing this does not fully dispel the unease that seems to cling to this region, the sense that we are looking not simply backward in time, but outward into something that resists our attempts at understanding. Perhaps it is the darkness itself, so total, so absolute, that human instinct recoils slightly from it. Perhaps it is the scale, distances so vast that light itself, the fastest phenomenon in the universe, takes hours rather than seconds to cross from one point to another. Or perhaps it is something more difficult to articulate, a feeling that emerges not from any single fact but from the accumulation of all of them together, the cold, the silence, the isolation, the sheer improbability that anything could exist, unchanged and untouched, for so impossibly long. Whatever the source of this unease, it does not diminish the region's significance. If anything, it deepens it, transforming the Kuiper Belt from a mere scientific curiosity into something closer to a meditation, a vast and silent archive holding within it the earliest memories of our solar system, waiting patiently, indifferent to whether we ever arrive to read them. Every object out there, every icy fragment tumbling slowly through that endless dark, carries a story written in a language of chemistry and physics, a story that predates not just human civilization but the very existence of life on Earth itself. And as our spacecraft, our telescopes, our instruments continue to reach outward, piece by piece, toward this frozen frontier, we are not merely exploring distant space. We are reading backward into our own origins, tracing the threads that connect the coldest, darkest reaches of the solar system to the warm, living world we call home. And it is in this act of tracing, this quiet archaeology of light and ice, that we begin to understand something else about the Kuiper Belt, something that goes beyond mere chemistry, beyond mere orbital mechanics, something that touches instead on the very question of how a solar system assembles itself out of chaos, and what gets left behind when the process is finished. Picture, if you can, the solar system in its infancy, a swirling disk of gas and dust rotating slowly around a newly formed star, a nursery of raw material stretching across billions of miles, dense in some places, sparse in others, driven by gravity and heat and the slow, patient accumulation of matter into larger and larger bodies. In the inner regions, close to the sun's warmth, rock and metal condensed first, forming the small, dense worlds we now call the terrestrial planets: Mercury, Venus, Earth, Mars. Farther out, beyond a boundary scientists call the frost line, temperatures dropped low enough for ices to form alongside rock, allowing giant planets like Jupiter and Saturn to grow massive envelopes of gas around solid cores, becoming the gas giants that now dominate the middle regions of our solar system. But farther still, past Neptune, past the last of the true planets, the disk of material thinned dramatically, and here, in this outer darkness, something different happened. The particles were too sparse, too widely separated, too cold and slow-moving to coalesce into anything as large as a planet. Instead, they remained small, numerous, scattered across a vast ring of space, never quite finishing the process of formation, never quite completing the journey from raw material to fully formed world. This is why the Kuiper Belt exists as it does today, not as a single failed planet, but as an entire population of almost planets, of worlds that began to form and then simply stopped, frozen in place both literally and figuratively, forever caught in that unfinished moment of creation. There is something quietly profound in this idea, something that resonates far beyond the technical language of astronomy. The Kuiper Belt is, in a very real sense, a place of arrested becoming, a region where the universe began to build something and then, for reasons dictated by nothing more than distance and time and the thinning of primordial material, left the work incomplete. Objects like Pluto, like Eris, like Makemake and Haumea, are not failures in any meaningful sense, but they are unfinished, caught permanently in a kind of cosmic adolescence, neither fully formed planets nor simple, shapeless debris, but something in between, something that exists in a category all its own. This in-between nature is part of what makes classifying these objects so difficult, part of what led to the prolonged and often contentious debates within the scientific community about how to define a planet in the first place. When Pluto was reclassified as a dwarf planet in 2006, the decision was not made lightly, nor was it made simply to diminish Pluto's significance. It emerged instead from a growing recognition that Pluto was not a unique outlier at the edge of the solar system, but rather one of many similar bodies, part of an entire population of Kuiper Belt objects that shared its essential characteristics, its size, its composition, its icy surface, its distant, elongated orbit. To continue calling Pluto a planet while ignoring the dozens of similarly sized bodies being discovered around it would have created a definition so broad, so inconsistent, that it would have lost any real scientific meaning. And yet, even now, this classification remains a subject of quiet debate among astronomers, a reminder that our human systems of categorization, our need to sort the universe into neat, discrete boxes, often struggle to accommodate the messy, gradual, continuous nature of physical reality. The universe does not organize itself according to human convenience. It does not draw clean lines between planet and non-planet, between finished and unfinished, between significant and insignificant. These are constructs we impose from the outside, useful for communication, but ultimately artificial when measured against the deeper truth of how these worlds actually came to be. Perhaps this is why the Kuiper Belt continues to fascinate scientists and dreamers alike, this sense that it defies easy categorization, that it exists in a state of permanent ambiguity, neither one thing nor another, but something quietly, persistently itself. It asks us to hold complexity without needing to resolve it, to accept that a region of space can be scientifically significant precisely because it refuses to fit into our existing frameworks. Every object within it, every icy fragment and elongated orbit, is a small rebellion against simplicity, a reminder that the universe is under no obligation to make sense to us, and that some of its most profound truths lie not in the answers we manage to extract, but in the questions that remain, patiently, permanently unresolved, drifting through that vast and silent dark. waiting not to be solved, but simply to be witnessed, again and again, by whatever small, curious minds happen to look upward into that endless field of stars, searching, as humans have always searched, for some fragment of meaning in the patterns of light scattered across the dark. Among the many objects that populate the Kuiper Belt, few have captured the imagination quite as powerfully as the dwarf planet Eris, a world discovered in 2005 that briefly threw the entire astronomical community into a state of quiet upheaval. For a time, Eris appeared to be larger than Pluto itself, a discovery that forced scientists to confront an uncomfortable question: if Pluto counted as the ninth planet, and if Eris was truly its equal or greater in size, then should Eris not also receive the designation of planet? And if so, how many other similarly sized objects might be waiting undiscovered in the depths beyond, each one demanding its own place in an ever-expanding list of official planets? It was this very question, this cascading uncertainty, that ultimately led to the International Astronomical Union's decision to formally define what a planet actually is, a decision that resulted, controversially, in Pluto's reclassification. Eris itself remains an object of profound cold and profound distance, orbiting the Sun at an average distance nearly 3 times that of Neptune, following a path so elongated, so eccentric, that its distance from the Sun varies dramatically over the course of its 559-year orbit. At its farthest point, Eris drifts nearly 15 billion kilometers from the Sun, a distance so vast that sunlight, traveling at the fastest speed the universe allows, takes over 13 hours to complete the journey. Imagine standing on its frozen surface, waiting for daylight, only to realize that the very concept of day and night as we understand them barely applies at all, that the Sun itself, in this location, is nothing more than an intensely bright star, offering no warmth, no color, no true illumination beyond a pale gray twilight that never fully brightens and never fully fades to complete darkness, existing instead in an eternal, unchanging dusk. The surface of Eris, as best as scientists can determine through the limited data available, appears to be covered in a bright, reflective layer of frozen nitrogen and methane, similar in some ways to Pluto's own icy surface, though considerably colder given its greater average distance from the Sun. This icy coating gives Eris one of the highest reflectivity ratings of any object in the solar system, meaning that despite its almost incomprehensible distance, despite the faintness of the sunlight reaching it, the dwarf planet actually appears remarkably bright when viewed from Earth, a strange paradox of a world that is simultaneously extremely distant and extremely visible, precisely because its frozen surface reflects back almost every particle of light that manages to reach it across those billions of kilometers of empty space. Eris also possesses its own small moon, named Dysnomia, a fitting companion given the mythological origins of Eris's own name, drawn from the Greek goddess of strife and discord. Dysnomia orbits its parent world in a tight, precise loop, and the interaction between the two bodies has allowed scientists to calculate Eris's mass with far greater accuracy than would otherwise be possible, using the same fundamental principles of orbital mechanics that allow astronomers to determine the masses of planets and stars throughout the universe. It is a strange kind of intimacy, this relationship between distant worlds, one body's gravity revealing the secrets of another, even across distances that defy ordinary human comprehension, even in a region so remote that human eyes have never directly seen the surface details of either body, only inferred them through indirect measurements, mathematical calculations, and the patient interpretation of reflected light captured by instruments built with extraordinary precision. What makes Eris particularly haunting to consider, however, is not simply its size or its distance, but the implications of its existence for our broader understanding of the outer solar system. If a body as large as Eris could remain undiscovered until 2005, hidden not through any deliberate concealment but simply through the vast, empty distances and profound darkness of its orbital path, then what else might still be waiting out there, similarly massive, similarly reflective, similarly patient in its multi-century orbit around a sun it rarely approaches? The discovery of Eris did not close a chapter in our understanding of the Kuiper Belt. It opened an entirely new one, revealing that our previous assumptions about the size and population of this region had been, in many ways, fundamentally incomplete. And so scientists continue to search, continue to refine their instruments, continue to scan the darkness for any flicker of reflected light that might indicate another hidden world, another Eris, another Pluto, another fragment of the solar system's earliest history waiting patiently to be found. Each new discovery reshapes our maps, forces us to reconsider our models, reminds us that the boundary of what we know is not a fixed and settled thing, but a living, evolving frontier, expanding slowly outward with every passing year, every new observation, every faint point of light captured. Patiently across the frozen silence of that outer dark, a silence that seems, the longer one considers it, to hold within it not emptiness but a kind of vast, unspoken presence, as though the void itself were less an absence of things and more a waiting room, filled with worlds we simply have not yet learned to see. Among these worlds, perhaps none demonstrates the strange, unexpected diversity of the Kuiper Belt quite as vividly as Haumea, a dwarf planet unlike almost anything else discovered within our solar system. Where most spherical bodies rotate at a measured, unremarkable pace, Haumea spins with astonishing speed, completing a full rotation in just under 4 hours, one of the fastest rotation periods of any known body larger than a few kilometers across. This extraordinary spin has stretched Haumea's shape dramatically, deforming what should be a sphere into an elongated ellipsoid, resembling, in the imagination of many astronomers, something closer to a rugby ball than a planet, its longest axis nearly twice the length of its shortest. To stand upon its surface, if such a thing were even conceptually possible given its violent rotation and extreme surface conditions, would be to experience gravity itself as something unstable, something that shifts subtly depending on one's position along that elongated frame, a world where the very ground beneath one's feet seems to warp and stretch the laws of physics into unfamiliar configurations. Scientists believe this rapid spin, and the resulting elongated shape, likely originated from a massive collision deep in Haumea's past, a violent encounter with another large body that not only reshaped Haumea itself but also created a family of icy fragments now scattered across similar orbits, fragments that share Haumea's unusual composition and appear to be remnants of that same ancient impact. This makes Haumea part of something rare within the Kuiper Belt, a collisional family, a group of related objects born from a single catastrophic event, their orbits still echoing, even now, billions of years later, the physics of that ancient collision. It is a humbling thought that the shape and structure we now observe through our most advanced telescopes represents not a stable, eternal condition, but the visible aftermath of violence, frozen in time and preserved across distances and durations that dwarf almost any timescale relevant to human experience. Haumea spins on, endlessly, a silent monument to an impact that occurred long before the earliest stirrings of life on Earth, its rapid rotation a kind of geological memory, still playing out, still unresolved, even after all this time. Haumea further distinguishes itself through its two small moons, Haumea and Namaka, named, like Haumea itself, after figures from Hawaiian mythology, a naming convention chosen deliberately to reflect the island-born origins of the astronomers who discovered it. These two moons orbit their parent world in complex, gravitationally intricate patterns, their movements offering scientists crucial data about Haumea's mass and internal structure, much as Dysnomia's orbit revealed similar secrets about Eris. And in 2017, astronomers made an even more surprising discovery, detecting a thin ring system encircling Haumea, making it the first known Kuiper Belt object confirmed to possess such a feature, a discovery that once again reminded the scientific community how little had truly been understood about the outer solar system's diversity and complexity. A ring system, once thought to be an exclusive characteristic of the massive gas giants, now confirmed around a small, distant, elongated world barely a fraction the size of Earth's moon, suggests that the mechanisms capable of producing and maintaining rings may be far more universal, far less dependent on planetary scale, than earlier models had assumed. It raises the question, quietly but persistently, of how many other small, distant worlds throughout the Kuiper Belt might harbor similarly unexpected features, rings, moons, geological activity, structures and characteristics that challenge our existing assumptions about what a small, cold, icy body is even capable of possessing. This is, perhaps, the deepest lesson embedded within Haumea's strange and violent history, that even the most distant, most seemingly simple objects in our solar system can conceal extraordinary complexity beneath their frozen surfaces, that appearances observed from billions of kilometers away, filtered through faint reflected starlight and painstaking mathematical analysis, often fail to capture the true, intricate nature of what actually exists out there in the dark. Haumea, spinning wildly through its 4-hour day, elongated and scarred by some ancient, catastrophic encounter, accompanied by its 2 small moons and its unexpected ring, stands as a quiet testament to the idea that the Kuiper Belt is not a uniform field of similar, unremarkable objects, but a genuinely diverse collection of worlds, each shaped by its own unique history of formation, collision, and transformation, each holding within it a story still only partially understood, waiting, like so much else in this region, for the right instruments, the right mission, the right moment of human curiosity to arrive and finally listen to what it has to say. And so we drift onward, past Haumea's frantic spin, into the deeper, quieter reaches where the sun has become little more than a bright and distant star, its light arriving thin and cold, offering barely a whisper of warmth to worlds that have waited billions of years in darkness. Here, in this hushed remove, we encounter Makemake, the third of the Kuiper Belt's officially recognized dwarf planets, a world that in many ways defies the wild, chaotic drama of Haumea's story, and instead offers something quieter, something more solitary, though no less strange for its stillness. Makemake was discovered in the spring of 2005, found by the same team of astronomers who had located Eris and Haumea within that same remarkable window of time, a period when our understanding of the outer solar system was expanding with startling speed. The discovery came just after Easter, and in a small act of whimsy, the astronomers considered naming it Easter Bunny before ultimately settling on Makemake, honoring the creator deity of the Rapa Nui people of Easter Island, a fitting tribute, perhaps, for a world that seems, in its own icy way, to embody the idea of creation frozen mid-thought, suspended in the long becoming that characterizes so much of the Kuiper Belt. Makemake orbits the Sun at a distance of roughly 45 astronomical units, slightly farther out than Pluto, completing one full revolution in just over 305 years, a span of time so vast that not a single human being has lived to see it fully unfold since the world was first observed. Its surface, when examined through spectroscopy, reveals something unexpected, something that sets it apart from many of its icy neighbors. Rather than being dominated by water ice, as is common among Kuiper Belt objects, Makemake's surface is coated in frozen methane and ethane, compounds that give it a reddish, ochre hue, not unlike the tone of Pluto's more famous heart-shaped plains, though Makemake's coloring emerges from a different chemical story, a different sequence of freezing and irradiation played out under a fainter, more distant sun. This methane ice, scientists believe, exists in large, coarse-grained crystals, suggesting that some process, perhaps subtle geological activity or perhaps merely the slow migration and refreezing of volatile ices across the surface, continues to reshape and renew Makemake's outer layer, even now, even in a place so cold that liquid water could never exist upon it, even in a place where the very concept of geological activity seems almost paradoxical against the deep, abiding stillness of such extreme distance and cold. For years, Makemake seemed to stand entirely alone, a solitary world without companions, an anomaly among an increasing catalog of dwarf planets that seemed, more often than not, to travel with moons. But in 2016, using the extraordinary resolving power of the Hubble Space Telescope, astronomers detected a faint, dark companion orbiting Makemake, a small moon now informally known as 2 Malawian Quachas, a world so profoundly dark, so nearly black in its reflectivity, that it stands in stark visual contrast to the brighter, icier surface of Makemake itself. This darkness is, in its own quiet way, deeply unsettling to consider, for it suggests a moon whose surface may be coated not in fresh, reflective ice, but in some older, more processed material, perhaps carbon-rich compounds or complex organic molecules darkened by billions of years of exposure to cosmic radiation, a small companion drifting silently through Makemake's cold light. Nearly invisible against the black backdrop of space, a shadow orbiting a world that itself sits at the edge of what our eyes, even our most powerful instruments, can meaningfully perceive. There is something profoundly evocative in this image, this pairing of a paler, reddish world and its nearly invisible dark companion, locked together in a slow gravitational dance far beyond the reach of sunlight's warmth. It calls to mind the way so much of the universe operates in pairs, in relationships of mutual influence that shape and define one another, even when one partner remains hidden, obscured, difficult to detect until the precise right conditions of observation align to reveal its presence. And perhaps this, too, offers something worth sitting with in these quiet hours, this idea that darkness does not mean absence, that a companion can exist, can exert real gravitational influence, can shape the very rotation and behavior of the world it orbits, all while remaining nearly imperceptible to the outside observer, hidden not by distance alone, but by the fundamental nature of its own composition, absorbing rather than reflecting the sparse light that reaches it. Makemake itself continues its slow, silent circuit around the Sun, following an orbital path more circular, more sedate, than the wild, inclined ellipse of Eris or the eccentric wandering of Pluto, a path that carries it steadily through the Kuiper Belt's outer reaches, accompanied by its shadowed moon, both of them locked in a gravitational embrace that will likely persist for the remainder of the solar system's existence. Two worlds bound together in the frozen dark, one bright and reddish, one nearly invisible, circling one another in a silence so complete, so absolute, that it becomes almost impossible for the human mind, accustomed to the warmth and noise of Earth, to fully grasp what such stillness, sustained across billions of years, might actually feel like, if feeling itself could somehow exist in such a place, waiting instead for the next observer, the next instrument, the next quiet moment of human attention to arrive and take notice, to translate distance and darkness into something resembling understanding. We move now, slowly, deeper still, toward a region of the Kuiper Belt that resists easy categorization, a zone where the objects grow fainter, smaller, more difficult to detect, where our knowledge thins not because these worlds are unimportant, but because the light they reflect back to us is so faint, so scattered across such immense distance, that even our most sensitive instruments strain to register their presence. Here we find Gonggong, a dwarf planet candidate discovered in 2007, named for a Chinese water god associated with chaos and destruction, a fitting name, perhaps, for a world whose orbit carries it through one of the most eccentric, most tilted paths of any object in this region. Gonggong's orbit is inclined more than 30 degrees from the plane in which most of the solar system's planets travel, a steep, wandering path that carries it from a perihelion of roughly 33 astronomical units out to an aphelion approaching 101 astronomical units, an orbital range so vast that Gonggong spends the overwhelming majority of its 550-year journey in the deep, frigid outer reaches of the Kuiper Belt, only occasionally drawing close enough to receive what little warmth the distant sun can offer. Its surface, like Makemake's, carries the reddish tint of complex organic compounds, tholins formed through the slow bombardment of ultraviolet light and cosmic rays acting upon simple ices over unimaginable spans of time, a chemistry of patience. A chemistry that requires nothing but darkness and time and the occasional touch of radiation to produce colors and compounds that hint at the raw materials from which life itself might once have emerged, here, in a place so hostile to life as we understand it, that the very idea feels almost like a contradiction, and yet the same molecular processes that may have contributed to Earth's early chemistry continue to unfold across Gonggong's surface, slow and silent and entirely indifferent to whether anyone is watching. Gonggong, too, has a companion, a small moon named Shangliu, discovered through careful observation using the Hubble Space Telescope, a moon whose presence allowed astronomers to finally calculate Gonggong's mass with reasonable precision, using the simple, elegant physics of orbital mechanics, The way one world's gravitational pull upon another can reveal secrets that no amount of direct imaging could ever hope to expose. And what these calculations revealed was a world less dense than expected, suggesting a composition rich in ices, a body perhaps 40% rock and 60% frozen volatiles, a ratio that speaks to the particular conditions of temperature and pressure and available material that existed in whatever distant, cold corner of the solar nebula gave rise to Gong billions of years ago. There is something worth pausing on here, in this quiet method of discovery, this way that a tiny, faint moon, barely visible even to our most advanced telescopes, can nonetheless unlock so much understanding about the larger world it orbits. It is a reminder that knowledge in this remote region rarely arrives through direct observation alone, but through inference, through the careful accumulation of indirect evidence, through mathematics applied patiently to fragments of light and motion, until slowly, incrementally, a picture begins to emerge, incomplete but meaningful, approximate but real. As we continue drifting through this scattered, sparse population of distant worlds, it becomes increasingly clear that the Kuiper Belt does not end neatly, does not resolve into a clean boundary beyond which nothing exists. Instead, it fades gradually, imperceptibly, into an even more remote and mysterious population of objects, the detached objects and extreme trans-Neptunian bodies, worlds whose orbits carry them so far from the Sun, whose perihelion distances are so large that they seem almost untouched by Neptune's gravitational influence altogether, drifting instead through some poorly understood dynamical space at the very edge of what we can meaningfully call the solar system. Objects like Sedna, discovered in 2003, embody this deepening mystery perhaps more powerfully than any other body yet found. Sedna's orbit is so extreme, so vast, that even at its closest approach to the Sun, it remains farther away than Pluto ever travels, and at its most distant point, it recedes to nearly 1,000 astronomical units, a distance so immense that light itself, moving at its impossible, unceasing speed, takes days merely to cross the gap between Sedna and our star. Sedna's orbital period stretches across more than 11,000 years, a span of time so vast that the entirety of recorded human history, every empire, every language, every war and discovery and quiet act of human wonder, could fit within a single one of its long, slow years and still leave room to spare. To consider Sedna is to confront a kind of temporal vertigo, a dizziness born not of height or depth but of duration itself, for this small, reddish world, drifting through the outer dark on its impossibly long orbit, was already in motion long before the pyramids rose from the Egyptian sand, long before writing was invented, long before human beings had begun to leave any lasting mark upon the world, and it will still be moving, slowly, silently, tracing its vast ellipse through the frozen dark, long after every trace of our present civilization has faded into whatever quiet dust remains of memory, of language, of the countless small human moments that once seemed, to those living them, so permanent, so central, so impossible to forget. Sedna's discovery forced astronomers to reconsider the very architecture of our solar system, for its orbit could not be easily explained by the gravitational influence of any known planet. Neptune's gravity, powerful as it is, could never reach far enough to shape an orbit so extreme, so detached from the rest of the solar system's dynamical structure. And so Sedna's existence opened a door to speculation, to careful, disciplined scientific hypothesis about what else might lie hidden in the dark beyond our current instruments, what unseen mass might have nudged this small, distant world into its impossibly long and lonely path. This is the quiet origin of what has come to be known, informally, as the search for Planet 9, a hypothesized world, perhaps 5 to 10 times the mass of Earth, that some astronomers believe may orbit far beyond even Sedna's reach, its gravity subtly shepherding the orbits of Sedna and a handful of other extreme trans-Neptunian objects into the strange, clustered alignment that observation has revealed. No one has seen this world. No telescope has yet captured its light, if indeed it exists at all, and there remains real scientific debate about whether this clustering is the signature of a hidden planet or simply an artifact of limited data, a pattern glimpsed too faintly, in too small a sample of objects, to be trusted fully. And so we are left, once again, at the edge of knowledge, standing at that familiar threshold where careful observation gives way to hypothesis, where mathematics and gravitational modeling attempt to reach into a darkness that our telescopes cannot yet fully illuminate. It is a humbling position, this act of searching for something we cannot see, inferring its possible existence only through the subtle, almost imperceptible influence it may or may not be exerting on the handful of small, icy worlds we have managed to detect so far. It is, in its own way, a kind of faith disciplined by evidence, a willingness to imagine what might be true, held always in tension with the requirement that such imagining be tested, checked, weighed against the accumulating data of each new observation. If Planet 9 exists, it would orbit the Sun at a distance so vast that its own year, its own complete circuit around our star, might last somewhere between 10 and 20,000 years, a span of time that dwarfs even Sedna's already incomprehensible orbital period, a world moving so slowly, so deliberately, through such profound darkness, that it would have completed only a handful of orbits since the earliest ancestors of modern humans first began to walk upright across the plains of Africa. To imagine such a world, cold and massive and entirely alone, drifting through a darkness so complete that our sun would appear as little more than a particularly bright star in its sky, is to confront once more the almost unbearable scale of the space that surrounds us, the sheer, staggering volume of emptiness within which our small, warm, living world continues to turn. But whether or not Planet 9 is ever found, whether it remains forever a compelling hypothesis or is one day confirmed through direct observation, its very possibility speaks to something deeper about this region of space we have been slowly, patiently exploring together. It speaks to the humility required of anyone who studies the outer solar system, the recognition that our maps remain incomplete, that our understanding continues to be revised and reshaped with each new discovery, each new faint point of light captured by increasingly sensitive telescopes scanning the same patient darkness night after night, year after year. The Kuiper Belt, and the more distant scattered disk beyond it, and the hypothetical structures that may lie even farther out still, together form a kind of frontier, not simply in the geographic sense of representing the outer boundary of our solar system, but in the deeper, more meaningful sense of representing the outer boundary of human knowledge itself, the edge where certainty gives way to careful speculation, where confirmed fact gives way to hypothesis, where the light of distant, tiny worlds becomes so faint that extracting meaning from it requires not just powerful instruments, but extraordinary patience, extraordinary care, and a willingness to sit for years, sometimes decades, gathering fragments of data before any coherent picture begins to emerge. There is something quietly moving in this, something that speaks not just to the nature of the Kuiper Belt itself, but to the nature of human curiosity more broadly, this willingness to look into darkness so profound, so absolute, and to keep looking, keep measuring, keep calculating, driven not by any immediate practical need, but by something more fundamental, some deep and abiding need to know, to understand, to map even the most remote and seemingly irrelevant corners of existence, simply because they exist, simply because they are there, waiting in the dark, for someone, somewhere to finally turn their attention outward, to lift their eyes, quite literally, toward the dark, and to ask, with whatever instruments and patience a given age of human history can offer, what lies out there, waiting to be understood. Let us drift, now, even farther from the warmth of the sun, past Sedna's long and lonely arc, past the hypothesized shadow of Planet 9, into a region that astronomers refer to simply as the inner Oort Cloud, a vast, spherical shell of icy bodies that may begin somewhere beyond 2,000 astronomical units and extend outward into a darkness so complete that the very notion of distance begins to lose its ordinary meaning. Here, the sun's gravity still holds sway, still exerts its slow, patient influence, but only just, only barely, its light reduced to a faint point among countless others, indistinguishable, to any observer who might somehow stand upon one of these distant icy bodies, from the thousands of other stars scattered across the black. The Oort Cloud remains, even now, a theoretical construct, inferred rather than directly observed, its existence proposed by the Dutch astronomer Jan Oort in 1950 as an explanation for the long-period comets that occasionally streak into the inner solar system, comets whose highly elongated orbits suggest an origin far beyond even the Kuiper Belt, in some vast, distant reservoir of icy material left over from the solar system's earliest formation. No telescope has ever directly imaged an Oort Cloud object. Their presence is known to us only indirectly, through the trajectories of the rare comets that occasionally fall inward, disturbed perhaps by the gravitational tug of a passing star, or the slow, cumulative pull of the galaxy's own vast rotation, sent tumbling toward the Sun on journeys that may take millions of years to complete. To imagine the Oort Cloud is to imagine a boundary so vast that it may extend nearly halfway to the nearest star, a shell of icy debris surrounding our solar system like some vast, invisible skin, holding within it the ancient, unaltered remnants of the very cloud of gas and dust from which the Sun and planets first coalesced more than 4.5 billion years ago. These objects, drifting in near-total darkness, subjected to almost no warmth, no light, no meaningful gravitational disturbance beyond the faintest whisper of the Sun's distant pull, may represent some of the most pristine, unchanged material remaining anywhere in the solar system, chemical and physical time capsules preserving, in frozen stillness, the conditions that existed before the first planet ever formed. There is a particular kind of awe available in contemplating this, an awe that asks us to hold two seemingly contradictory truths at once: that we ourselves, our bodies, our planet, our sun, all emerged from the same vast cloud of primordial material that also gave rise to these frozen, distant fragments drifting at the very edge of the solar system's gravitational reach, and yet that the paths taken by that shared material diverged so completely, so absolutely, that some portion became a warm, living, breathing world, capable of producing curiosity itself, capable of building telescopes and launching spacecraft and asking questions about its own origins, while another portion remains exactly as it began, unchanged, untouched, drifting through a darkness so complete that billions of years have passed without a single meaningful alteration to its frozen form. We are, in some very real sense, made of the same stardust as these distant, silent objects, and yet the story that unfolded for us, the long chain of chemistry and geology and biology that eventually produced life, then consciousness, then the particular human capacity to look upward and wonder, represents one path among countless possible paths that matter might have taken, one thread pulled from the same vast tapestry, transformed by circumstance and time into something capable of reflection, while so much else remained simple, elemental, frozen in the same basic form it held at the very beginning. Perhaps this is part of what makes the Kuiper Belt, and the more distant Oort Cloud beyond it, so quietly compelling to consider in these still, late hours, this recognition that we are looking, in some sense, at our own origins, preserved in a form untouched by the long, transformative journey that shaped our own world. Every comet that falls inward from these distant reaches carries with it not just ice and dust and organic molecules, but a kind of message from the earliest moments of our solar system's formation, a fragment of the original material from which everything familiar to us, every mountain and ocean and living creature, ultimately emerged. And so as we continue drifting through this vast, dark expanse, past dwarf planets and their shadowed moons, past hypothesized worlds still waiting to be confirmed, past the theoretical boundary of the Oort Cloud itself, we begin to understand that this region we have been exploring is not merely a distant, empty frontier, but something closer to a vast, silent archive, holding within its scattered, frozen bodies the earliest chapters of a story that eventually led, against extraordinary odds, to us, to this quiet moment, to this small warm world turning gently beneath a sky full of stars, to the particular arrangement of matter that somehow, against odds too vast to meaningfully calculate, learned to ask questions about the darkness from which it came. It is worth pausing here, in these final quiet moments, to consider what it means that we are capable of this at all, that a species born on a small, rocky planet, orbiting an unremarkable star in an unremarkable arm of an unremarkable galaxy, has managed to build instruments sensitive enough to detect the faint reflected light of objects billions of kilometers away, has managed to calculate the orbits of worlds so distant that their years last longer than the entire span of recorded human history, has managed, in short, to reach outward with the mind even when the body remains bound so completely to this single small world. There is something almost impossibly moving in this, something that deserves to be felt slowly, without hurry, in the quiet hours when the ordinary noise of daily life has finally fallen away. The Kuiper Belt, we have come to understand, is not simply a scattering of icy debris left over from some ancient, uninteresting process of planetary formation. It is a living record, still being written, still being read, a region where the earliest history of our solar system remains preserved in forms both simple and extraordinarily complex, from Pluto's nitrogen glaciers and layered blue hazes, to Eris's dense and violent history, to Haumea's wild spin and fractured family of icy fragments, to Makemake's dark and distant companion, to Gongong's steep and lonely orbit, to Sedna's almost incomprehensible journey through the outer dark, each of these worlds a chapter in a story that stretches back to the very beginning of everything we know, and forward into a future that will likely long outlast any of us, any of our languages, any of our civilizations. And perhaps this is the quiet lesson worth carrying with us, out of this long, slow journey through the outer dark, and into whatever rest now awaits. That the universe does not require our attention in order to continue its slow, patient unfolding. Pluto's ice will keep flowing, in its own imperceptibly slow way, whether or not any human eye remains to observe it. Sedna will continue its 11,000-year arc through the darkness, indifferent entirely to whether we remember it exists. The hypothesized world we call Planet 9, if it is out there at all, will continue its own vast, silent circuit, unconcerned with whether we ever manage to confirm its presence. And yet, despite this profound indifference, despite the universe's total lack of need for our witness, we continue to look, we continue to measure, we continue to ask, because something within us, some deep and essential part of what it means to be human, finds meaning not in being needed by the universe, but simply in the act of paying attention to it, in the quiet, patient work of trying to understand. This, perhaps, is what makes the Kuiper Belt and all its scattered, distant worlds so worth returning to, again and again, in these still hours before sleep, this recognition that curiosity itself, this simple, persistent desire to know what lies beyond the reach of easy sight, may be one of the most quietly remarkable things our species has ever produced. Not the telescopes themselves, not the spacecraft, not even the vast catalogs of data slowly accumulated over decades of careful observation, but the underlying impulse that drives all of it, this refusal to accept the darkness as simply empty, this insistence that even the coldest, most distant, most seemingly insignificant corners of existence deserve our attention, our patience, our care. So let this be where we rest, for now, somewhere out past Neptune, drifting slowly among worlds that have waited billions of years in silence and cold, worlds that ask nothing of us, expect nothing of us, and yet reward us endlessly whenever we choose to look. Let the last image carried into sleep be this: countless small, icy bodies, scattered across an almost incomprehensible expanse of darkness, each one holding some fragment of the story of how everything began, turning slowly, silently, in orbits that will likely continue long after we are gone, indifferent and patient and utterly, quietly beautiful in their own frozen stillness. And somewhere among them, perhaps, a comet begins its million-year fall toward the sun, disturbed by some faint gravitational whisper too subtle to trace, beginning a journey that will not complete for longer than human civilization has yet existed, carrying with it the oldest, most unaltered material in our solar system, a small, drifting messenger from the very beginning of everything, moving now, slowly, silently, through the vast and patient dark, toward a warmth it will not reach for a very, very long time.